Hi students, welcome to physics class. Welcome to our physics class. Today we are going to discuss about time of flight, horizontal range, velocity of object of horizontal projectile. At first, time of flight. Time of flight. It is the total time for which the projectile is in flight is called time of flight. It is the total time for which the projectile is in flight. Once again, it is the total time for which the projectile is in flight is called time of flight. That is the time taken by object to go from O to C. From O to C. Let it be capital T. Once again, it is the total time for which the projectile is in flight is called time of flight. The time taken by object to go from O to C. Let it be capital T. Now see the diagram. Take x-axis, take y-axis. A body is projected with a velocity u so that it will be hit the ground at a point C. It is O. Now the O to C is the total time of flight. It is y. Now HB, the vertical height of point from here to O to Y point is H. Let H be the vertical height let H be the vertical height of point of projection point of projection O from C. Once again I am repeating this point. Let H be the vertical height of point of projection O from C. Since motion of object since motion of object along OY direction once again, since motion of object along OY direction is given by, that is S is equal ut plus half a t square, but OY direction means S suffix y is equal u suffix y into t plus 1 by 2 a suffix y into t square. Because of OY direction, sy is equal to uyt plus 1 by 2 ay t square. Here s is equal to y is equal to h and uy is equal to 0, because the vertical component of velocity freely falling body uy is equal to 0 and ay is equal to plus g and small t is equal to capital T. Now substitute all these physical quantities in the above equation. Consider this is equation number 1. Therefore, we will get y is equal to O capital T plus 1 by 2 G capital T square. Finally, we will get y is equal to G T square by 2. Tell me what we will get? Y is equal to gt square by 2. Once again, what we will get? We will get y is equal to gt square whole by 2. But here y is equal to h. Therefore, h is equal to g t square whole by 2. Therefore, t square is equal to 2h by g. Therefore, t is equal to root of 2h by g. Consider this is equation number 2. This is the time of flight. Therefore, the time of flight of horizontal projection t is equal to root under root 2h by g. Now we are going to discuss about horizontal range. Once again, horizontal range. It is the horizontal distance traveled by the projectile during its flight is called horizontal range. Once again, it is the horizontal distance traveled by the horizontal distance traveled by projectile during its flight. Once again, it is the horizontal distance traveled by projectile during its flight is called horizontal distance. That is the horizontal distance covered by object while going from O to C. That means, once again I am repeating, it is the horizontal distance traveled by the projectile during its flight. The horizontal distance covered by the object while going from O to C. Let it be R, capital R, since motion of object along OX direction once again, since motion of object along OX direction, therefore S is equal UT plus half AT square. This is second equation of motion, we know. Therefore, Sx is equal to Ux t plus 1 by 2 Ax t square. Therefore, x is equal uxt plus Sx is equal uxt plus 1 by 2 Ax t square. Ax t square because horizontal direction. Here S is equal x is equal R, that is equal Sx is equal x is equal R. and ux is equal u and ax is equal 0 and small t is equal capital T is equal root of 2h by g. Substitute these physical quantities in equation number 1. Therefore, we will get x is equal ut plus 1 by 2. What is x? 0. 0 into t square. X is equal u into t, and that implies x is equal u into what is t? T is equal capital T. Then what is capital T? Therefore, x is equal u into capital T. X is equal u into what is capital T? Capital T is equal root 2h by g. Therefore, what is x? R is equal x is equal u into root 2h by g or ut or u small t. Therefore, all are same. R is equal x is equal u into root of 2h by g. Consider this is equation number 2. This equation gives horizontal range of object on horizontal projection. Now we are going to discuss about velocity of object. Velocity of object, that is projectile. That is projectile at any instant. Once again, velocity of object, that is projectile at any instant. Now take x-axis, y-axis. It is y. The object is hit the ground when it is projected with velocity u. Now this is point C. This is point O. Here take a point. Consider this is A. Take a vertical vector, that is B. The point name is P. Now take this is the resultant, that is PD. This PD makes an angle beta with x-axis or with vector PA. With vector PA. Now take this is ux. Ux is equal u. Take this is uy. Uy is equal 0. The reason is freely falling body. Uy is equal to 0. Consider this is the resultant. This is u. Similarly, consider velocity, final velocity components. This is Vx. Vx always called as Vx, and downwards or vertical components Vy. That is, we don't know, we have to find. And this is resultant V. Once again, I am repeating the points. Consider it is Ux. The Ux is equal to U, and this is Uy. The Uy is equal to 0. Consider this is resultant, that is U. Similarly, for the final velocity component, Vx is nothing but Vx, and this is Vy. That we don't know, we have to find. This is resultant. The resultant is V. That means if a body coming downward direction, initial velocity is u. That is resolved into two rectangular components, ux and uy. Here uy is equal to 0, ux is equal to u, because the starting is u. Similarly, the final velocity v resolved into two rectangular components, along x component dx, along y component vy. That we have to find. Now, yet that instant at the instant small t, the object possesses two perpendicular velocities. Two perpendicular once again, I am repeating this point. At the instant small t, the object possesses two perpendicular velocities. One is horizontal velocity, second one is vertical velocity. One is horizontal velocity, and the second one is vertical velocity. Vertical velocity. Now, the horizontal velocity, nothing but ux. The horizontal velocity vx. That we don't know. And the vertical velocity vy. That also we don't know. These two we have to find now. Now we are going to find horizontal velocity vx and vertical velocity vy. At first, horizontal velocity. That is Vx question mark. At first, horizontal velocity Vx question mark. Now see, Ux is equal to U and Ax is equal to 0 and Vx, that we have to find. Okay, Now go for discussion. We know that V is equal to U plus AT, because horizontal Vx is equal to Ux plus Ax t. Consider this is equation number 1. Now what is Vx? Nothing but Vx, that is equal to Ux means consider U plus Ax means 0. Therefore Vx is equal to U, or Vx is equal to U, or Vx is equal to Ux. Okay, therefore we understood that Vx is equal to Ux is equal to U is the horizontal velocity. Therefore horizontal velocity is Vx is equal to Ux is equal to U. Once again, the horizontal velocity is equal to, we will get Vx is equal to Ux is equal to U. Consider equation number 2. Now we are going to discuss about vertical velocity. Now vertical velocity. The vertical velocity is Vy. Now see, here for vertical velocity, Uy is equal to 0 and Ay is equal to plus G and Vy. We don't know, but we know that from the first equation of motion, V is equal to U plus At. But this is vertical. Vertical means we have to write as Vy is equal to Uy plus Ayt. Consider this is equation number 1. The above physical quantities substitute in 1. Therefore, Vy is equal to, what is Uy? 0 plus what is Ay? G into T. Therefore, Vy is equal to Gt. Consider this is equation number 2. Therefore, the vertical velocity Vy is equal to Gt. Once again, the vertical velocity Vy is equal to Gt. Now, we are going to discuss about resultant velocity of Vx and Vy. Now see, the resultant velocity. Here, the resultant velocity V of Vx and Vy is given by, once again listen carefully, the resultant velocity V of Vx and Vy is given by V is equal to root of Vx square plus V y square. Now what is Vx square? Here Vx is equal to Ux is equal to U. Just now we derived. Similarly, Vy is equal to G capital T. This is also G T. This is also we derived. That is equal to Vx is equal to Ux square plus G square T square. And also V is equal to under root U square plus G square T square, because Ux is equal to U. This is also resultant velocity. Now let V makes an angle. Let V makes an angle beta with the horizontal direction. Then what happened? Now first see the diagram. Take, it is Vx, it is Ux, it is V, it is U. Now take, this is Vy, this is V, it is beta. That means let V makes an angle beta with the horizontal direction. In that case, tan beta is equal to opposite side by adjacent side, that is Vx by Vy. What is Vx? Sorry, that is Vy by Vx or Vy by Ux or Vy by U, because these three are same. Therefore, tan beta is equal to Vy by Vx. What is Vy? Gt by what is Vx? Vx is equal to U. Consider this is equation number 1. Therefore, tan beta is equal to G T by Vx. That implies beta is equal to tan inverse G T by Vx. Okay, this is equation number 2. Similarly, tan beta is equal to Gt by Ux. That is equal to, that implies beta is equal to tan inverse G T whole by Ux. Consider this is equation number 3. Similarly, take tan beta is equal to Gt by U. That implies beta is equal to tan inverse of G T by U. Consider equation number 4. Remember carefully why we are getting three angles, because Vx is equal to Ux is equal to U. Once again see the diagram. This is Vx, this is Ux, that is U. Here this is Vy. This is resultant V. This is beta. That means tan beta is equal to Gt by Vx. Tan beta is equal to Gt by Ux. Tan beta is equal to Gt by U. What is Vy? Here Vy is equal to Gt. What is Vy? Vy is equal to Gt. So that is why we are getting the angles like this. My dear students, I hope you understood this video. Thank you very much for watching this video. Thank you.